Good morning.
Hello. So I'm not streaming this to Zoom. I think I'm just recording it to the cloud, or not streaming it to YouTube. I think that's what I don't know what I should do here, because I think what was happening with the YouTube links is like Dana was going through them and like putting them in the right category. I don't know what this fits into, so I don't know. I could be doing this all wrong. I really don't know what I'm doing here.
As long as it's recorded, it can eventually be posted somehow, right? So
Yeah,
it
I
doesn't
guess
really
that's true.
matter.
Yeah. But in general, how'd React go? How's servers going? It's a whole new world.
Good. Yeah, definitely everything we learned in your module has been helpful. So it's going well.
Susan liked the server stuff. That's good.
Yeah.
Me too. I
Yeah.
actually feel like the server stuff seems to be going more smoothly given all the other stuff. Kind of what Kyle just said, but I feel like I like the server more.
Okay. Yeah, I'll put out maybe the leading notion that you're still at the beginning of all the server stuff and it's gonna get more complicated. Um but like, yeah, I mean it's different. That's for sure. I'm maybe gonna wait a couple more minutes just because some other people said they were gonna join, then I'll get into it. But so I've just put some more slides at the end of my module 5 presentation. So I'll post that link again too if anyone wants to follow along.
Hey Ryan, will we need anything up? Like, are we going to be looking on the web or anything?
I'm basically going to go through these slides. I've got a couple little demos.
Okay.
That's basically about it. There's not really any code you have to write per se as part of this.
Okay, thanks.
Yeah, I didn't there's no sort of homework or anything. Like this is just, I mean, the homework is I'm gonna do some demos and show you some stuff. And like if you want to try to rewrite those on your own, like you could do that. Okay. I think I might just get started here because people aren't coming. So WebSockets. The backstory here is Latonia sent me a message and said, I want to learn more about WebSockets. So I said, okay, I'll do a thing. And then I just offered it to everyone, and anyone who wants to join could join. So just in general, like who's heard of the term WebSocket? So any sort of familiarity going in here from anyone?
Not until I read a little bit about it after your message went on Slack. And
Okay.
Max talked about it a tiny bit in last week. Yeah.
Okay. Oh, wait a second. I just gotta. Okay. So WebSockets, they're technology that solves a very sort of interesting problem on the web. And that's what I've kind of deemed the push problem. So typically on the web, all sort of communication over HTTP is client initiated. So what that means is the client makes a request to the server, and the server does some thinking, and the server then returns a response back to the client, and the client gets that data back in response. So it sort of follows that request response paradigm. And that works most of the time. But that doesn't work all the time. What if you want the server to send data to the client without the client sending a request first? So like, what if you want the client, oh, Nathan joined, nice. What if you want the client to send data to the server? Or sorry, what if you want the server to send data to the client, but you don't want there to be an initial request being required by the client? So like, what if you want the server to be able to push data to the client dynamically? And you might kind of ask, like, why is that important? Or what sort of benefit does that have? Like, well, really the canonical example is any sort of thing that live updates. So some examples of that, like a messaging app. You type out you have a messaging app open, and then you get these sorts of messages that pop up from people that you like receive messages from. And like, that's not something where you're making a request and you're somehow getting that data back. Like, that's coming from the server. It's like being pushed to you. And there's no sort of client initiated part there. So like, that's one example. Maybe another example is like a social network. Let's say you're on Twitter, you've got this big list of tweets, and you're following all those people, and you want tweets as they send them to kind of populate automatically to live update in that big tweet timeline. It's another example. Maybe one more, a collaborative editing. So you're in Google Docs. You've got the two people who are working on a single document, and somehow you need to be able to let them both like update the same document. And since they're on different computers, that data has to make its way, has to be pushed from one system to another. So like, let's say I've got a document open and someone else's document open, and they type like a word in there. That word needs to show up in my document somehow. So these are all sorts of things that they don't really fit the workflow that we've designated with HTTP. There's not like a request response lifecycle there. So the typical workflow is request response. What we kind of want is something more like this, where like the server is sending data directly. There's no sort of request response part involved at all. So how do you do this? So of course you can guess the answer is WebSockets, but like we're gonna kind of get there. That's sort of the end part. We're gonna talk about 3 different ways you can accomplish this. The first one is just using this technique called polling. This is the simplest way to do it, and probably the easiest to implement. And what it effectively is it's like a kid in the back of the car asking, "Are we there yet?" over and over and over. So what you do is every few seconds, as a client, you make a request to the server, and then the server returns back any push data that this client should have since the previous request that was made. You just kind of loop this over and over. And it's really easy to do because you're just using the same technologies you're familiar with. You're effectively making that, because you're making that request over and over, you're kind of you're forcing the server to be able to send information on an interval.
We actually just did this with the chat app we were working on with Max.
Oh, okay.
So.
Yeah. So I made a little demo of this. I made a demo of each of these ways you can accomplish it. And just as a prerequisite before I go into the demo, like each of these demos, the kind of example I've got is I've got on the server, I've got a counter. This counter just keeps incrementing. And every single time the counter increments, it sends a message from the server to the client. So what happens is, like, you can see it here. We've got this message here, and it updates. So this counter goes from 1 and just keeps counting up. I've also included a timestamp, just kind of to be thorough, so you can kind of see like the time at which the server generated that message. And then I've also put a reset button in here, which you can click, and what it'll do is it'll reset that count back to 0 again. So what's the code for this look like? So this is the polling example. So it looks kind of like this, relatively straightforward. Really the meat of it is here. So periodically on an interval, every 2.5 seconds, let me zoom in a little bit. Every 2.5 seconds, this function calls, it makes a request to this endpoint I made /poll, gets the response, and then it just puts it into this div over here on the page. So if I do like module5.ml/poll, you can see an example of what that looks like. So just get some JSON back. And that's just what shows up here. For the reset, I may have another endpoint here you can make a post to, /reset. And basically that just, like, on the server side, that just sets that back to 0 again. And then I just set the contents of this to something that's makes it clear that the reset was processed, just to give the user some feedback. So yeah, and you saw that, like there, I just clicked it and it quickly reverted back. That's because that poll is independent of the reset button. So like I clicked it and just so happened that poll happened immediately. Maybe you'll click it again, it'll take a second. And that's because like the poll is happening and it's not interleaved at all with that reset. So that's polling. Sounds like that's something you're kind of already familiar with. One last thing, I just put in a request to initially populate it. Like if I got rid of this, it would take 2.5 seconds for that first thing to show up. And I just wanted to show up immediately. So I just made a request right away too. But yeah, that's polling. About the easiest way you can accomplish a sort of pushing behavior. So pros and cons, really easy to implement. Easy to scale. We're going to talk about this later, but this is an important consequence of how polling works. The cons are, of course, it's not instant. So you're always kind of on a few seconds ago delay. And for some things, that's totally fine. An example of like where polling might be really useful. Let's say maybe you've got a form where like you want to process a file. So maybe you like have a user upload like an image and maybe the image has to be resized or something. So the user uploads the image and then they like save it. And then like the web page is kind of waiting for that image to be processed. That's sort of a solution where like polling might work relatively well because it's easy to do. And you're already kind of waiting for that image to be processed. There's already kind of a delay there. So because there's a delay kind of built into the process, if you have to wait another couple seconds, like it's not that big of a deal. So the sort of like process like that where like you do a thing and you're waiting for the server to like compute a long running result, that's where polling works pretty well. There was one other thing I was going to say here. Ah, crap, left my mind.
Ryan, I have 2 quick questions if I can
Yeah.
jump in. I was reading yesterday about the difference between TCP and UDP. Is that okay? So this would be an example. Is it a TCP? And then like the
Antonia, you
images?
always ask the deep questions.
Oh, we can skip it then.
No,
We can,
it's fine. All web communication happens over TCP.
oh, all of it. So UDP would be like a subset or
UDP is a protocol that is it's very similar to TCP, but TCP gives you guarantees that the order of the packets that get sent underlying in the network they guarantee that the messages you put into one end always will come out the other end in the same order and like with like guarantees that you'll receive them too. So like UDP, you could think of it more like there's sort of a pipe in between 2 computers, and one computer can put in a message into one end, and there's no guarantee that the computer on the other end is going to receive it, or if they're going to receive it like in a timely fashion. So like they might not receive it, they might receive it late. Like there's all these sorts of guarantees that UDP doesn't have. And the reason why that's important is like there are some protocols where it's more important that like the information go through fast than it be reliable and like always be in order. So like an example of that is like video streaming, where it's more important that you see the latest frame of the video, and if you miss an old frame, it doesn't really matter.
Okay, thank you. That's a great example. And then my other question was when you showed us that and you saw how the counter increased by 1, didn't you teach us something? What was it called where you can set the counter not to increase, where you can basically test something and it won't increase it, it keeps it set to the initial value? Do you remember teaching us about that? I remember you going over something. If not, I can try to find it.
Yeah, if you can give me an example, I can try to elaborate, but nothing comes to mind at the moment.
Yeah, I can't think of an example. It just said, basically it was talking about how you can keep the counter the same, basically to like keep the integrity of whatever you're testing so that it doesn't increment each time. That's all I can remember, but that's okay. I can go back to our older videos. Thank you.
Yep. Okay, so that's technique 1, polling. Before I move on, any other questions? Okay. So what if you need something closer to real time? Like polling's great, but like that delay is kind of problematic. I mean, imagine you had to wait like a couple seconds whenever you wanted to receive a message in a messaging app. Like that's kind of inconvenient. And I do want to address the elephant in the room here. Like you could poll really fast, but that has a lot of downsides too. Like there's a lot of network traffic you're having there. it can, depending on how the polling's written, overwhelm the server in certain ways. Like polling fast is typically a bad idea. Like probably polling at an interval less than like maybe 500 milliseconds or like a second is usually bad. So what if you need something closer to real time? Well, next technique we're going to talk about is long polling. It's similar to polling, but a little bit different. So in this case, the client makes a request to the server, but the server doesn't respond to the request immediately. It kind of like keeps the request open. So it's like the server is sort of waiting before it gives back a response. And then once the server has information to push, it sends back the response immediately, which means the client gets the data instantly or close to instantly. And then after that request completes, the client makes another request. So there's not really a delay in long polling. It's sort of it's a process where every client always has a connection open to the server at any time. So if the server wants to send data, it has a method by which it can do it. So to kind of show this in practice here, I would make a request to an endpoint, say like long poll, and that request would kind of stay open. It would hang and just be there. The server would kind of be waiting and waiting and waiting. And then at some point, okay, I need to make this push. So then it responds to that request, and the push data comes back, and it's at the client. And the client makes another request, and this sort of cycle keeps repeating. So let's do a little demo of that. So this is doing the exact same sort of counter. In this case, you can see it updates. And then similarly, I can click reset, and it'll process the reset. And then it'll go back down to 0 again, or 1, I guess. And yeah, same sort of rough idea. If we take a look at the source code for it, though, it's a little bit different. So the reset is pretty much the same, but the pull function is a little bit different. So notice there's no set interval here. There's no sort of repeated like time-based thing. What happens is I call this pull function, I call that, which calls in here. And then in here, I make a request to get long poll. And then once I get back the response, I put that into here. And then I call this function again. So it runs this again, and then it runs this again. And it just does it over and over and over and over. And the other thing that's worth pointing out is if this fails in the catch, I call it again too. So like whether this request is successful or not, I'm always calling that request. And I always want to have one request in flight in progress. And I didn't do this with the polling, but I probably should have gone into the network pane here. You can see here how this is pending. It stays pending and then eventually resolves to get back the data. And this one's now pending. And like there's always a request that's pending. So that's kind of the deal with long polling. You always have a request pending into the server. So does that make sense? So pros and cons. Long polling, really easy to implement. Data is pretty much in real time. The cons, it's harder to scale. So this isn't going to mean all that much to you yet, but it will kind of hopefully later on. In general, having requests that are open for a long period of time usually puts a lot of load on the server. And the reason, like one request per active client means that if the servers often can only handle a certain number of requests at any given time, like they can only handle a certain number in parallel. So if your limit is like 10 and you have 11 clients, then that 11th client's requests are going to fail. So there's sort of some scaling implications there. Again, may not mean all that much to you yet, but you'll hopefully get to it later on in the DevOps module later on. And Nathan's going to be teaching that, I think. So I asked Nathan if he wanted to join. Nathan's my old coworker. So this harder to scale thing is actually kind of a big con. It's kind of a big deal. doesn't really mean all that much to you now. And for like smaller projects or like local sorts of things you're working on, things that aren't being deployed to a large, massive user base, it's probably fine. But like, it's the sort of thing you want to be cognizant of if you're working on sort of a large scale application. So when you start to scale up a system, this is actually a pretty big deal. There's one active request per client at any point. So how do we solve this problem? And this is where we get to, well, what we sort of want is we want netcat. Like we want a TCP socket, a raw socket that we can use to send messages between clients. We want like a bidirectional communication mechanism. That would really be the goal, because we can then get rid of all this sort of HTTP calisthenics we're doing. Like it would be great if we could just have like a pipe. The server could send whatever it wants through that pipe. The client could get it on the other side. That would be ideal. And as you can probably imagine, that's what WebSockets provides. So WebSockets is sort of like a way you can implement something like a raw TCP socket between a server and a client. So that means bidirectional communication is fine. There's no sort of request response involved. It means pushing information can be done in a real-time fashion, or as close to real-time as possible. It means that the client doesn't have to do anything funky. The client can just make a connection, and then every single time a message comes in, they get notified the message comes in, and they can send messages, and the same thing will happen on the server. It makes a lot of problems a lot easier. So how does WebSockets work? So I was a little wrong by saying there's no sort of HTTP calisthenics. There's a little bit involved to make it happen. So the way WebSockets works is it starts by making an HTTP request under the hood. It's just a regular HTTP request like you would normally expect. But it includes a special header, this header called the upgrade header. There's a couple other headers you got to include, but that's really the key one. And that upgrade header is set to the value WebSockets. And when the server receives a request with this upgrade header set to WebSockets, it sees, oh, the client was requesting that I upgrade to WebSockets. And if the server supports WebSockets for that endpoint, it'll return back the special status code 101 switching protocols. Now, remember way back when we were talking about status codes, 200s are good, 400s mean the client did something wrong, 500s means the server did something wrong. We talked about 300s, now we're getting back to 100s. So like 100s aren't used for very many things, but this is one of the places where they show up. So you get back a 101 switching protocols. And then at that point, the connection sort of is just like a TCP socket, where you can put messages in one end, you can get messages out the other, bidirectional communication. So because it's done as sort of an HTTP, it's done on the web, you have to start it with an HTTP request. Remember how we were talking about on the web, typically that's how web browsers communicate. So it was done that way sort of for backwards compatibility. But basically, like, once you've gone through this sort of setup dance, you have a TCP socket you can use for back and forth communication between a client and a server. So what that actually looks like is you make a get to your WebSocket URL or whatever that is. This upgrade WebSocket header is passed. The server says, oh, the client would like to upgrade. So it returns back a 101. And then the client says, okay, we've now got a WebSocket. And at that point, you can just send data either way. Like there's no sort of restriction on that client server sort of request response paradigm. Okay, so important things to know. The biggest thing, WebSockets don't use the HTTP or HTTPS protocol. They use a special protocol called WS or WSS. So when you want to connect to a WebSocket, the URL you're going to use to do that isn't like HTTP : / whatever. It's like WSS : / whatever. Now, what's weird is that it's a different protocol, but it still uses the same HTTP ports. And the reason why it does this is because it sort of starts over the HTTP protocol. Like, I think this is sort of a weird decision on their part why they did it this way. But like, effectively, you're starting the communication over HTTP, so it's done all over those ports, and then eventually you devolve into just a raw TCP socket. You can think of WebSockets as sort of like an extension of HTTP. It's like they started with HTTP's protocol, and then they added some stuff to it to allow you to later on kind of perform that bidirectional communication. Okay, demo. So this is the same thing, only with WebSockets. So reset works, all that. It's great. But WebSockets are cool. You can see here, I've got this WebSocket endpoint to the status is 101 switching protocols, kind of what you'd expect. And you can go in here and you can see like we've got that upgrade header. There's some other headers involved here too, which are a little more complicated and could go into it at a different point if you're curious. But the important thing is like this upgrade header. Now you'll notice, if you just look at any request, you typically have this preview response thing up here. But for WebSockets, you have this thing that says messages. This is really pretty cool because you can watch all the messages that get sent by the WebSocket. So like these are all the things that are coming from the server to the client. And if I click reset, these are all the things that get sent from the client to the server. And it'll even do the nice little JSON parsing thing for you if you want. But you can see here how the server is just sending a message. Like I'm connected to this WebSocket, and the server is just like publishing updates for me every few seconds about the updated state of that counter. And you can imagine if you had like a messaging application, this maps really well to like a messaging thread. Like someone could type in a message and click send, and the thing gets sent. And then someone else sees that message get sent to them via the WebSocket, and they make it show up. And then they type a message into their messaging thing, they click send, and then that message gets sent similar to the way this got sent and gets sent back. And then maybe that server then processes sending that to all the other clients, and they get back a thing that says they received a message. So this works really well for certain sorts of problems. Now you'll notice that I decided I wanted to do the reset here a little bit differently. Before I was doing the reset by making a request. But here I'm doing the reset by actually sending a message on the WebSocket. This kind of demonstrates another sort of technique here where you can use a WebSocket in sort of a request response paradigm still. Like you can, I'm sending a request here, and if I actually click reset, you can see it. Like I immediately get back one of these count messages. So this is kind of like a request and kind of like a response in concept. There's no real downside to doing that. In some cases, it actually can make your life easier. Actually, fun story, at one of the first companies I worked for, I built a dashboard that did all of its communication over WebSockets and implemented a whole sort of protocol there. And it meant that it was like a really real-time live-facing use case. So it was nice because every single time there was an update, like the client could just respond based on those WebSocket messages. And I also, this may not mean anything to you if it doesn't just ignore it, but like I tied it into Redux. So I could basically, I was sending actions from the server all the way to the client. And it was like a really nice sort of way that I could sort of like dispatch actions in the server. Anyway, maybe means nothing to you, but it was pretty neat. So for certain sorts of problems, WebSockets work really well. But let's take a look at the source code, and we can see here what this looks like. So this is actually kind of simpler than the long polling, and maybe even the polling example. Really, this is like pretty much it. In the browser, there's this global called WebSocket. And what you do is you create a new one, or you call this, and you give it a path to that WebSocket. And to be clear, I just put that window location, the host in there, just to make it easy for me to test this locally. But like, that's what it basically is. So it window.location.host is equal to module5.ml. But notice that WSS, so I'm not using HTTP there, I'm using WS, very important. And then get back this sort of like thing, this WebSocket thing. And then you can add this event listener to the WebSocket. And every single time a message is received, this function will be called with the message. So turns out there's a data property on the message that contains like the raw text of the message. So I just took that, I just put that up here. And that's about it. If you want to send something, there's a send method you can call. So just sent some JSON that says type reset. Typically you'd sort of have you'd come up with a sort of protocol if you want to send and receive data like that. But yeah, that's about it. One other thing I want to call out. Notice you don't really have, you're using this WebSocket global built-in, you're not using Fetch, or you're not using Axios, you're not using any of those tools, which means you don't really have access to the underlying request being made. So like that initial request to create the WebSocket, you don't really have much control over that, which means, for example, let's say you want to include a custom header in that request. Too bad, you're out of luck, you can't. Browser just doesn't give you that ability. They give you a pretty limited interface. So if you want to include parameters to this, basically your two options are you can include them as URL parameters, or you can include query parameters like question marks, hello equals world sort of thing. Those are basically your two options. Also, similarly, you can't change the method. So all WebSockets are gets, like all the initial requests are gets. In other sorts of libraries and other sorts of tools, like maybe if you were trying to make a WebSocket connection in Node, like Node can of course be a WebSocket server, but you could also make like a client connection in Node. In that context, you might be able to find a library that gives you that control, but the browser built-in WebSocket library doesn't give you that control. And in fact, like there's really no way to get that back because all the sort of other tools that use the WebSocket built in at the lowest level. So like you can't really get that functionality in there at all because the browser doesn't expose it. So that comes up because sometimes you want to make your request more custom and you just can't. Or sometimes what really happens is people who work on the back end don't know that that's a limitation. They say like, oh, send this header along with your WebSocket request. And you have to tell them, actually, no, you can't do that from the browser perspective. So anyway, I want to also show you that these are actually sharing a counter, this WebSocket and the long pulling, all these examples. So what I can do is take this guy here, put it over here, and I can click reset, and you can see that, oh, wait a second. It's not going to work. I tested this just an hour ago, and it worked. Okay, well, now it's not going to work. Great. But what should happen here is if I click reset on one of these, it should reset all of them. Or like the counters will actually increment synchronously. Like you can see it goes 1 here, and then it goes to 2. They both change at the same time. So like this, there's a single sort of counter state being shared between all these demos. So if you want to kind of play around and see like what the implications are, like if I go over here to the polling demo, you can actually see this takes a little longer to update. So like 6, 5, like it doesn't go instantly. And that's a consequence of the polling being like a thing done on an interval. So you can kind of get a lot of interesting behavior if you play around with these demos. Okay. So that's a really basic primer introduction to WebSockets. I've got a couple more things I'm going to talk about related to it, and then I'm just going to open it up to questions, and then we're done. I found this really good post that's a technical deep dive on how WebSockets work. If anyone wants to go deeper on it, that's a good resource. And you'll if you read into it, you'll realize that I have done a bit of oversimplifying here. There are some more complex things going on when you said WebSockets messages and stuff like that, but you don't need to know that necessarily. Just as like a user of the thing. Okay, yeah, I already talked about the code. So you make a new WebSocket connection, you do this add event listener dance, and then you have access to your data. If I were to just like stick this over here, well, and I didn't try to reuse a variable, like you'd see that I just start logging out data. So yeah. Okay. So just like there's Fetch and there's Axios, and Axios is kind of a higher level implementation on top of Fetch, or higher level library. There are higher level WebSockets libraries too. And I kind of hinted at this earlier. And these tools kind of give you some extra abilities or extra features. One thing is really old browsers don't support WebSockets. And if you need to support them, sometimes you have to fall back to these older technologies like long polling or polling. So some of these technologies will sort of do that for you transparently. And there's like a server part of the module and a client part of the module, and they kind of take care of the transport layer, and they'll use whatever the best transport is for your browser. There are other things where like they'll handle sending data in special formats, or like give you the ability to like subdivide things into like channels or like groups or of messages and stuff like that. So they're kind of higher level primitives. And the four that probably are the ones that I know about that you might run into. Socket.io is probably the most popular one in the JavaScript ecosystem. So that's like a node server and a browser client. Microsoft has this one called SignalR. Never used it. I have a coworker who's used it and says it's good, but I tend to not trust his opinion on Microsoft things because he's a big fan of Microsoft things. Yeah. Phoenix channels and Django channels. So Django channels is a thing with the Django framework in Python. That works pretty well if you ever go down that road. And I got to throw in Phoenix channels. I'm a big fan of Elixir and Erlang and that whole system. And they have a technology that is a higher level primitive too. That's pretty cool. But in general, like probably the one you're gonna, if you want to use one for your capstone, Socket.io is probably the choice you'd go with. They're all about the same, like they all kind of have the same functionalities. They all kind of fall back to the whatever transport the browser supports. They all have like the subdividing the WebSocket into different groups. Like there's all these sorts of standard features they add. Okay, last thing. I think last thing. Yeah, scaling WebSocket servers. So remember that HTTP requests are short-lived. So you make a request, get back a response. Largely after that, the connection will close. So TCP sockets for an HTTP request, they're kind of short-lived. Their length is measured in like milliseconds. WebSockets require that TCP connection to be open for a long time, like seconds to minutes to hours even. That can make managing those connections more complex. So often, again, maybe you haven't talked about this yet, but maybe it'll make some sense. When you're deploying servers or you're managing production systems, there's a sort of philosophy that you can take a bunch of servers and you can run them. And if one server gets into a bad state or you want to restart a server, you can do that easily. You can just like kill it and then a new server will spin up and will kind of take its place. That becomes kind of hard because with WebSockets, you've got underlying TCP sockets talking to that server. So if you kill it, you're going to disconnect all those WebSockets. So there's sort of a dance you have to do where you have to make sure the client understands that the server can die and the client has to like reconnect again and connect to other servers. So with HTTP, because those connections are so short-lived, you can just kind of like, they will, systems are in place that'll easily just retry those connections, or there's a little bit more durability there. And those connections are short-lived, so like the client could even, or the server could even wait for those connections to finish before it terminates. Like there's a lot more flexibility there. But because the WebSocket connections are long-lived, there's sort of some problems. There's also some problems with this term horizontal scaling. I'm not going to go into that now, but like there are certain other ways in which scaling WebSockets are hard too. This is typically when you hear people who are like, I don't want to use WebSockets, this is why they're saying it. Like they don't want to have to worry about this whole like class of problems. So how big of a deal is like these class of problems? They're kind of a big deal, especially if you're someone who manages infrastructure or like low level things. So there is kind of a solution to this. There are services out there that will sort of outsource all this logic for you. And what I mean by that is you make your WebSockets connection to them, and then you make an HTTP request to their servers to say, please send the message to all the clients, and then they'll do it for you on your behalf. So effectively, you're paying someone else to manage all the WebSockets infrastructure, to scale it for you, to do all that. And you don't have to worry about it. And you just get an interface that's easy to work with from just as like a web API. So pros, easy to get started, easy to scale it, like a lot of good things. The cons are cost money. So usually you have to pay per push. So for things that are like low frequency pushes, that might make sense. If you're building a messaging app where you'd have to pay for every single message someone sends, maybe not such a good idea. Really just, I want to make it known that like these are available. If you don't want to worry about trying to make a WebSockets thing for like your capstone, Pusher, PubNub, Ably, those are kind of the three ones I've heard about. I have the most experience with Pusher. It works decently well. Yeah, so that's that. And typically what the interface they give you is something kind of like this, where you can run import a library into your server. You can run a function. And then on the other end, you sort of do something very similar to the WebSockets thing. You subscribe to a channel, and then you have a handler, a function that gets called every single time a message is received. So like easy interface from a developer's perspective, really nice to work with. But if you were working at a company that was about to have explosive growth and didn't have a ton of money, maybe a thing to consider at least. But that's it. That's about all I really have to say on it. WebSockets is pretty cool. For certain sort of applications, they work really well. Any questions?
I have a question. Back on the data slide where you were actually sending data through the WebSocket. Can you go back to that?
Talking about this?
I'm sorry, the code where you do a ws.send.
Yeah. This.
Yeah, I'm just curious on that type reset. How did you choose that data? Is that a special kind of message that you're sending? Did you come up with that yourself?
I came up with it myself. Yeah, so effectively, when you're using WebSockets or really any sort of network communication, you've got to come up with a protocol. And it's the same sort of thing as if you were making a request to like a REST API, where that REST API has sort of a specific format it expects for the body of its request, for example, like to create a new thing. Or there's a specific sort of way you have to send information. And this is just, I just decided, hey, I want to, this is the format I want. I kind of chose this because thinking ahead, like as one should often do with protocols, I was thinking ahead and realizing if I wanted to extend this application in the future, maybe wanted to add like an ability, like a new type of command. I wanted to give myself something where I could stick another thing in here and I could like add a list of commands later on. So that's kind of why I went with this, but this could just as easily be like just some random data. It doesn't have to even be JSON. You could like, you could send like binary data over this. You could send like an image if you wanted to. So.
Okay, so what you're putting into the WebSocket is of your own choosing. It's not that there's some underlying spec here.
Correct.
Okay.
So I hate to slow us down, but can you just explain what you just explained again?
Yeah.
So maybe get a handle on it. When he says that when you say you came up with that, what does that mean?
So this message here, this message is not something baked into the WebSockets system itself. I just chose a message of my own format to send here to reset. I could just as easily have named this key like action or something, or I just as easily could have made this like just send like 1, 2, 3 to reset a thing. The reason why I picked this message is because I wanted to send, so first of all, I wanted to send JSON because I wanted a sort of a format that was a standard format I could use. So that's the reason why I picked JSON. And then the reason why I picked this particular format of this particular layout of the JSON is because I wanted to ensure that by having a type in here, I can now in the future add more actions to the front end. So like, let's say I wanted to add an action like reset counter to 5. I could add a new type called like reset to 5. And then I could send a message that says like type reset to 5. And then this, basically I have like one message format that then on the server side, when I'm parsing it, I can just look at that type key and know what kind of message I'm parsing. So it kind of has some nice properties when you do it that way.
Could you have sent like the number 1 as a way to represent a reset message?
I could have, yeah. So that's something you'll often see a lot more in like lower level code, especially where like memory constraints are more important, where instead of sending like the string reset, they might give like a list of values, like maybe like let's say like reset maps to 1. reset to 5 maps to 2 or whatever. And then you'll send that number, and that number can be compressed smaller than the text string effectively. I'm giving that a roundabout explanation, but like there are ways in which that is a smaller, easier to parse bit of data for lower level languages. So it's possible. I would say though, in JavaScript, unless you have some special circumstances, there's probably not a good reason to do it. In my opinion, at least, spelling it out all the way is probably the more readable, more easy to digest way to do it. I am kind of curious. So, Latonia, I know you were curious about WebSockets. Does anyone think that WebSockets might be part of their capstone now after hearing about all this?
I'm wondering if this is used in mapping. Like I'm going to be using a mapping API. Obviously, I'm not going to make one, but I'm just thinking about like the GPS automatically updating the image of where you're standing as you're walking and stuff like that.
Yeah, that's totally a way. If you're well, I'll take that back. That could be, it could be used in that way sometimes. So if the client is the thing determining where you're located, then of course, like you don't need to send that information from the server to the client because like the client already knows it. But like if, let's say, maybe another example is like you wanted to have a point, you wanted to track someone else's location on your map. Like someone was uploading their GPS coordinates to a server and the server was sending that down to your map and showing a little dot that like followed them. That's a great example where you'd use this. In general, as like a rule of thumb, you probably should prefer to use HTTP over WebSockets if you can. And what I mean by that is reinventing requests and responses and just using a WebSocket for that is usually considered an anti-pattern. Like it's usually better to do that over HTTP because there's HTTP features that are better suited for that. Like there are things like caching and things like you kind of have to reinvent the protocol again if you want to do it over WebSockets. You can. There's really no reason you can't. It's just like HTTP already exists, so usually you would just use it.
This is probably a little deep, but do you know what the maximum frame size that can be sent over WebSocket is?
Oh, not off the top of my head, but there is a maximum, yeah.
Do you have like a gut feeling around what that is? I don't even know.
I would guess in like the 0.5 meg to a meg range.
Yeah, you mentioned sending images through this.
Yeah.
Would you have to chunk the image first and then break it?
You probably would, yeah. Or the other way you could do it is you could, so just to clarify what Nathan's saying, if just to make sure you folks get it, like typically the messages you can send over WebSockets, there's a maximum size they can be. So you can't just have a string that's infinitely long you're going to send over the WebSocket. Like there's a upper limit. That upper limit is pretty high, like on the order of 1 megabyte or so, I think. Again, I'm just going off the top of my head, but like that's a rough order of magnitude. So if you're just sending like the name of something of like a thing a user typed into a text box, you're probably going to be fine. But if you're sending like an image or something that's larger, that can be a problem. So what Nathan was saying with chunking is like one thing you could do is you could take that image and you could break it up into smaller sections and send each section as a message, and then on the other hand, reassemble it. Another thing you could do is you could, if the image is coming from the server to the client, the server could upload the image somewhere on the web and send the client a link to the image, and then the client could download it from the web. So you can, you're kind of like sending a handle to where the image is located. That's maybe another technique, but lots of different ways you can do it.
Is that covered at all in the extra material you put into when you said you provided a deep dive into WebSockets? I actually work a lot with creatives, a lot of video, a lot of images. So that would be of interest to me.
It's, I don't think it is. I think it's just more about the protocol itself. But as far as like, as far as how you'd actually do that, I mean, it's relatively straightforward. Like imagine you, imagine like you had a place you could store files on a server and you like save it into a folder. And then you make an endpoint that like serves files out of that folder. So like you make a request to like a path and like it just gets the data out of the file and sends it back to the client. And then from in the WebSocket, it just send like the link the client should make a request to get the thing. So like you effectively construct that URL ahead of time and send it to them over the socket. If you want, I can write out a little example for you and send it to you afterwards. Anybody else have anything? Or is that about it? Oh, I haven't been watching the chat. Gosh, I'm used to having a TA doing that. Ugh. Cool. Yeah, well, that's about all I've got. Unless you've got any other questions, I think we're done.
Thanks, Ryan. I hope you felt like this was worth your time. Appreciate it.
Definitely. Hopefully it gives you some perspective into some new things you can do in the browser.
Is that just the same? Yeah, I have your link bookmark from your original, the weeks that you were teaching. So those will just show up on there, right? The link to the
Yeah, I just stuck it at the end here.
Yeah. Okay. So then I already have it. I don't need the link. Cool.
Yep. I also put the link in up here too.
Oh, okay. I hadn't looked at Slack yet. Okay. Thanks.
Yep.
Thank you so much for taking extra time to do this. This is interesting.
Yeah. No problem. I'm glad it's helpful. Well, I'm going to be a TA for Nathan in a few weeks, so I'll see you again then. But yeah, I guess until then, see ya. See you around.
See you, folks.
Thanks.
Bye.
Nice to see you.
Bye.